It's find the shortest path from node O to node T. So node O, path cost is 0, heuristic is 12. So in the frontier, the tuple 12 total cost, node and path will be added. Then it's going to be popped, then it's going to explore OA, OB, OC. So 3 neighbors. At A, path cost is 2. Heuristic at A is 11. So total cost is 13. 13A, OA will be added to the frontier. And B, path cost is 5 and heuristic is 9. So 14B, OB will be added to the frontier. C, cost is 4, then heuristic is 10. So 14C, OC will be added. Actually, the tree will have 13A, OA as a root, then 14B, OB, 14C, OC will be left and right child in the min-heap. When the AOA popped, it's going to swap first and last first. So 14C, OC will be at the root. Then when A is popped, I'm going to use a green color. Now, A cannot go back to the O because O is in the path. So A will have 3 adjacent, B, D, and F. So when A go to B, path cost is now 2 plus 2, so 4. So path cost at B is updated as shortest one as 4. Then heuristic is still 9. Total cost 13 is up to B, is updated, and 13B OAB is added. So 13B OAB is added at the end, then it's gonna do heap up. So 13B OAB is now in the root. Then 14C OC comes back to the right child. Yes, Carolina?
Does it work like a set? Like, can there be multiple nodes with the same value? Or will it get replaced?
It's gonna have 2 things. Yeah, 13B, 14B.
Okay, thank you.
I don't really have to delete from the 14B because deleting is B O N. I do not want to remove from the list because a heap is faster than removing. Then now OAB is done. Now OAD. When I OAD, the path cost is 2 plus 7, so 9. Then heuristic at D is 4. So total cost is 13. So 13 D OAD will be added. So when it added to the left at the end, it's gonna do heap up. So 13D OAD is in the first left child and 14B OB is on the bottom. That's added. Then F. Path cost up to F is 2 plus 12, so 14. And heuristic at F is 3, or 17. So 17 F, OAF is added at the end. Now, I'm going to use blue. When it popped, it's going to swap first and last and pop. So 13B OAB and 17F OAF will switch the, and 13B OAB is popped at this time. It's a state. And 17F OAF will heap down. So it's going to go to the left child. So now root has 13D OAD. Then 17F OAF will swap heap down one more time. The left child will have 14B OB. then child will be 17FOAF. So this is my current tree. So I'm going to remove a little bit, erase a little bit to make it clear of a current tree, like this. This is my current tree. Now I'm going to extend it from the BOAB. So blue color, OAB. From the B, it cannot go O, it cannot go A, because O and A are already path. So B can go to C, E, D. I'm going to do C first with the blue color. Path cost is 2 plus 2 plus 1, so 5. The previous one was 4, so smaller, so I do not do C. Do not add C to the adjacent. Then, when I go to D, 2 plus 2 plus 4 is the path cost, so path cost is updated as 8. Then 8 plus 4 is 12. So on the frontier, 12D OABD is added. So 12D OABD starts from the bottom, and it's going to heap up. So swap first with the 14BOB, then swap with 13DOA, so 12DOABD is now at the root because it's 12. Then also E should be added. E is path cost is 2 plus 2 plus 3, so 7. And heuristic at E is 7, so it is 14. It's added to the right child, left of the child, so that is 14 E O A B E is added. So this is my current tree. And all the children they are added. Now next time when I pop it, I'm gonna go red. 12D OABD will be popped. So OABD is popped. After it's swapped with the bottom one. So temporary root is 14EOABE. And 14EOABE will do heap down with the left child. So 14EOABE is the left child now. Then 13DOAD is in the root. So if I delete some unnecessary part, now this is a current tree, the current heap. Then I'm going to extend from the 12D OABD. From 12D OABD, I cannot go to B, but I can go to E, I can go to T. So I'm going to use now, by using red. OABD path cost is up to here is 8 plus 1 is 9. E already has a shorter one, that means you don't have to add E. But T never explored yet, so path cost is 8 plus 5, so 13. Heuristic at T is 0. Total cost 13. Then T, OABDT is added to the heap, and it's going to do heap up. So swap with parent, so 13T OABDT, then 14DOC goes to the bottom. This is the current tree. So now iter 4 will happen. Currently, the root is 13DOAD, so it's going to be popped after swap with last node. So now 14COC is on the root, then 13DOAD is popped. And 14COC is off position, so it's going to keep down. So swap with right child. So 14COC is a right child now. Finally, 13TOAD will be in the root. Then I need to expand DOAD. So I'm going to use OAB, this path, this black path. So from D, can go to D, but when I go to B, the path cost will be 8 plus 4. It's not good. Actually, this path cost is 9 plus 4. 12 is not smaller than what B currently has, so do not go to B. And when it goes to D, E, path cost is now 9 plus, what is that? 1, so 10. It's not smaller, so don't add E. When D goes to T, path cost is now 9 plus 5, so 14. 14 is not smaller than what T previously has, so do not add T to the frontier. So nothing is added. Then DOAD is done. Now next time it's going to pop from to root 13TOABDT. Then it passed the goal test. So this is the shortest path.